So today it is 11/4/19, and we're going to be talking about all 6 trig ratios from the unit circle. Okay, all 6. So our 6 trig ratios we already had. I'm going to put them up here. I'm going to write them real quick. We have sine. We know a sine of theta is equal to the y value over the r. We know cosine is equal to the x value over the radius. Tangent of theta. Of course, you guys have these probably in your notes. I'm just going to put them up there to help us out. Tangent is going to be the y value over the x value. Cosecant of theta is the opposite of sine. It's the opposite of sine. So it's going to be the radius over the y value. Secant of theta is the opposite of cosine. So it's going to be the radius over the x value. And finally, cotangent is the opposite of tangent. So it's going to be the x over the y. Okay, good. So if we have all those up there, and I'm going to highlight them all because we're going to use it in just a second, okay? So on the unit circle, if it says unit circle, first of all, we need to remember, it says find all 6 trig ratios for pi thirds. So pi thirds is on the unit circle, right? So we automatically know that the radius is 1, correct? Well, let's do the easy stuff. Sine of pi thirds. All right. There it is. Sine is the y value. Square root of 2. Easy. Cosine pi thirds. Cosine is the x value, 1/2, right? Tangent of pi thirds. Well, tangent is really going to be my y over my x. But we already did the work, right? We already did this divided by this, and the answer is right there. Square root of 3. Makes it easy for us, right? We've done the tangents. Okay, square root of 3. Now, if I have to do cosecant of theta, it is going to be, so if I go to, oops, pi thirds, my bad, pi third, it is 2 over the square root of 3. How'd you get that, Landon? It's the opposite. So it is 2 over the square root of 3, which is totally correct. Can we fix it so it looks nicer? Sure we can, right? Multiply it by square root of 3 over square root of 3, right? And we're going to get an answer of 2 square roots of 3 over 3. Secant of pi thirds. It's the reciprocal, big word, it's the reciprocal of cosine. So it's 2 over 1, or just plain old 2. Good job, Landon. Tangent of pi thirds. It's going to be the reciprocal of tangent, so cotangent. It's going to be 1 over the square root of 3, but we can't have that answer, so we fix it, right? Like Zoe said, we fix the problem with the problem, right, Zoe?
That's right.
Square root of 3, square root of 3, so we wind up with a better answer of the square root of 3 over 3. Not too bad? Thumbs up? Okay, again, I will emphasize to you, though, we rarely use cosecant, secant, and cotangent, okay? Now, find all 6 trig ratios for pi halves. Okay, well, sine of pi halves, cosine pi halves, tangent pi halves, right? So, sine of pi halves. Let's see, sine is the y value, so it's going to be 1. Agree? Just plain old 1. Okay, so sine of pi halves is 1. Cosine of pi halves, cosine is the x value, so it's 0. Okay. Tangent of pi halves. It's going to be the y or the x. You're going to go 1 divided by 0? 1 divided by 0? Cookie Monster is not happy with that answer. Undefined. Undefined. In fact, we'll find when we graph these, we'll Put an asterisk. Now I'm going to put this symbol to make it easy for us right here. Okay? That means undefined. Okay, that's not 0. It's not the opposite. It really does mean undefined. Okay, that's going to be undefined. Okay. So then, if I wanted to go and do cosecant of pi halves, what do you think that's going to be? 1, because it's 1 over 1. We flip it, it's still 1 over 1, okay? Cotangent is going to be, so from cosine to secant, we're going to go secant of pi halves. It's going to be 1 over 0, but that's going to make Cookie Monster unhappy also. Undefined. Because you can't divide by 0, right? Okay, then cotangent of pi halves. Now this one's a little tricky because we said it was undefined, right? Well, let's flip this. Let's go 0 over 1, which is 0. 0 on the top's okay, right? 0 on the top's okay. Okay. Now, where else do we have problems with tangent? So if tangent, let's think about tangent right here. Add 0. What's the tangent value right here? Well, 0 over 1, which is what?
0.
Good, 0. Pretty good. I'm going to put that in my circle. Okay. Negative 1 over 0, or 0 over 1. 0 over negative 1. What's the tangent? 0 over negative 1. What's the tangent value?
0. No,
it's 0. 0. So that's 0. Well, what about down here? We're going to have negative 1 over 0.
Undefined.
This one's undefined. And we'll put this symbol of the empty set, but it really means undefined. Okay? All right, so we've got the unit circle is. So tangent cannot be 90, and tangent cannot be 180. Here's a really easy example. Also, remember when we did our hot air balloons? And even our rockets, right? Think about this. Okay, one more time. Think about this. You're doing your hot air balloon.
The gun.
Can you possibly get a height from here?
No.
You can't, because you can't get that length, can you? So it's another illustration of what happens. You cannot have tangent of 90 degrees, can you?
And you can't go.
No, you can't do that either. You can't do that either. Okay, let's keep going. Find the following. Cosine of 2 pi thirds. Let's see if you guys can do it. Cosine 2 pi thirds. See if you can do it without my help. Cosine of 2 pi thirds. Celeste, say it. Celeste said negative 1/2. Everybody agree?
No. Yeah. What? Oh, yep.
2 pi thirds. Cosine is the x value. Nice job, Celeste. All right. Celeste is going to hold on a little quicker before you give him a little more time, smarty pants. Okay. Tangent of negative pi thirds. Well, if positive pi thirds is to here, right?
Oh, is that negative square root of negative?
Negative square root of 3. It is negative square root of 3 because positive pi thirds is here, so we rotate backwards on our tire to here. Tangent value is right there. Okay, cool. Sine of 19 pi fourths. Well, that's not on there, but let's do this. So let's go. 4 goes into 19 how many times? Doesn't go in 4 times? 16 with 3 left over. So the same thing as saying sine of 4 and 3/4 pi. You okay with that? 4. So this is like 4 and 3/4. Okay, now, this is easy. Watch. Watch. 1 pi, 2 pi, 3 pi, 4 pi, 3/4 pi to 3. Right here, what's the sine value?
Negative. Oh, square root 2.
Yeah, square root. Okay, square root 2 over 2. So it should be square root 2 over 2. Okay. Secant. Okay, now secant's going to be the 1 over the x value. I'm going to write that down right at the bat. It's 1 over the x value. So 2 pi thirds is here. What's the x value? So it's 1 over a negative 1/2, right? Yep, it's 1 over negative 1/2, which flips it up to a negative 2. Pretty easy? Okay. Cosecant, 5 pi fourths. Let's see, that's 1 over the y value, right? So 5 pi 4s is here, right? 1 over the y value, okay? So I got 1 over a negative square root of 2 over 2. What are you going to do with that?
You're going to switch it.
Switch it. So we're going to rewrite it as 2 over negative square root of 2. A little rule that you probably know but you might have forgotten, and that is 1 over any fraction just flips the fraction up. Okay, I don't know if you remember that or not, but it always does. Okay, 1 over any fraction just flips up. Okay, but now this answer is correct, but it's not in the right form. So how do we fix it? Square root of 2 over square root of 2. So I'm going to get 2 square roots of 2 over negative 2. You okay with the negative 2? Okay.
Yeah.
So I get the square root of 4, which is 2, and then I'm going to cancel the 2's, right? Cancel these 2's. And I'm going to wind up with negative square root of 2, okay? Cotangent, negative pi 6. Well, cotangent is the x over the y, or it's 1 over the tangent value. It might be easier to just do 1 over the tangent value. But, so if pi 6 is here, right, then negative pi 6 is here. Okay, what's the tangent value?
Negative square root of 3 over.
Or it's going to be this over this, right? This over this. Which one do you want to do? X over y, or do you want to just flip this?
Just flip that.
Just flip that, okay? So I take the tangent value, we'll flip that. Or it's 1 over the tangent value, which is what you guys want to do. So it's 1 over my negative square root of 3 over 3, which becomes a flip it. Flip it because of the 1 over. 3 over negative square root of 3, right? Fix the problem with the problem, right, Zoe?
Yep.
Square root of 3, square root of 3. Wind up with 3 square root of 3 over negative 3. Am I going too fast? Am I doing okay? Not too fast? 3's cancel. Negative square root of 3. So here's what I know, just to impart a little bit of wisdom, okay? Because it's super easy. But these two are opposites. These two are reciprocals of each other. Square root of 3, square root of 3 over 3. If you flip this, you get square root of 3. If you flip this, you get this one. Okay? Now, turn the page, right? Now, use a calculus. Sine of 2. Okay? So and I want to do it in terms of radians. So if I want sine of 2, now think about this. Before we do it, let's get a visual. Okay? This is 3.14. This is right here is 3.14. Okay, so 1 radian is about 57 degrees. Here's 1. So 2 is right about here. Okay? I really want you to understand what we're going to find. The sine is the y value. My answer, I think, is going to be, this is 1. This is a 1, correct? The height is 1. I bet my answer is going to be about 0.8 something. I'm just guessing. Does that make sense why I get about 0.8? So the height from here to here, what's the height from here to here? 1. So if I'm right here, what do you think the height is maybe here? 0.8. I'm just guessing. So let's try it. Calculator. So if I get a calculator, the first thing I'm going to do is change my mode. Now the mode is important. Mode is important for the first time ever. So I go to my mode, and I'm going to make sure my mode is in radian modes, okay? Otherwise, what we're finding is a 2-degree angle, totally different. A 2-degree angle is right about here. See the difference in radians versus degrees? If you did sine of 2, it's right here, degrees. Sine of 2 radians, it's right about here somewhere, okay? Totally different spot, isn't it? So if I just use my calculator, quit, and I go, okay, sine of 2, I can answer about 0.9. Well, I guess 0.8. It's close. 0.909. So it's about 0.909, okay? Secant of 1.2. Now, I don't have a secant button in my calculator.
Are you sure?
I don't. But what is secant? Isn't it 1 over cosine? Isn't it? I can do that. 1 divided by cosine of 1.2, and I can answer about 2.76. 2.76, okay? All right. How am I doing so far? Okay, now, example 5. If cosine of t is equal to 3/5 and is in quadrant 4, find the other 5 trig ratios. So here's how we're going to do this. Let's go ahead. It says quadrant 4. Let's draw a little quadrant. Quadrants 1, 2, 3, quadrant 4. I'm gonna make a triangle in quadrant 4. So make a triangle in quadrant 4 that's going to look like this. It always needs to be flush with the x-axis. Okay, there's my right triangle. Okay. So I know I'm in quadrant 4. I'm going to do, instead of circle trig, I'm going to do right triangle trig. And I know that because what's my radius? What's my radius? What's my radius? It's 5. Isn't my radius 5? My radius is 5. It's no longer 1. So I'm not going to use the unit circle because the unit circle has a radius of 1. So now I'm not on a circle, but I can draw a triangle. What do I know about cosine? Cosine is adjacent over hypotenuse. You guys agree with that? So here's what I know. I know that cosine is going to be adjacent over hypotenuse, right? So I know that my x value is 3. I know my radius is 5, but I need to find my y value. Well, that's easy. I bet you can already tell me what it is. I'm hoping you can. We can do, what is it?
No, 5.
3.
Evan, go ahead. Don't you guys, what's our special right triangle? You guys, what? 3, 4, 3, 4,
5.
Degrees.
Anyway, how about we just do Pythagorean's theorem? So x squared plus y squared equals r squared. So or that's the same thing as a squared plus b squared equals c squared, right? Isn't that the same thing? I mean, Pythagorean's theorem says you've got a, b, c, right? Which is x, y, r. So my Pythagorean's theorem also works
Wait,
on...
it's 4.
Yes, thank you.
Say what?
I said 4. Like,
Yeah. Yes, you're right, Landon. So if we don't know it's 4, let's just use Pythagorean's theorem. Okay, so we're going to go 3 squared plus y squared equals 5 squared, right? 9 plus y squared equals 25, right? I've got y squared equals 16 because I subtracted 9, right? Now, how many answers?
2.
2. So y is equal to plus or minus the square root of 16, right? Or y is equal to plus or minus 4. Now, is it really 4?
It's minus or plus.
It's actually negative 4.
Dang, right.
Look at the picture.
Can't it be?
Look at the picture.
Oh, because it's in that it's in the fourth
Ah, so because it's in this quadrant, cosine's positive, but not the y value, right? So, and we can look at the picture. You're going to go over 3, but you got to go down. You got to go down, so it's got to be negative 4. It just has to be negative 4. So it must be y equals negative 4, negative 4. So the quadrant was important, wasn't it? So now I know that y is equal to negative 4. Okay, so you ready? Here it gets easy. Boom, you ready? Sine of t is equal to y over r. What's the answer?
oh, negative 4 over 5.
Bam. Cosine of t is equal to the x of the r. What's my answer?
3 over 5.
Bam. Tangent of t is equal to my y over my x.
Negative 4 over 3.
Boom. My cosecant of t is equal to my r over my y, which is my
5 over negative 4.
5 over negative 4. My secant of t is equal to my r over my x, 5 over 3. And finally, my cotangent of t is x over y, which is 3 over negative 4. Boom! Was that easy or what?
Wait a minute.
Okay.